Sebastián Martinez, and we have a problem for a company. So it says that the company needs to make a rectangular boxes without a lid with a volume of 500 centimeters square, and it is desired that the dimensions minimize the amount of cardboard. So we know that the amount of cardboard, we mean the area. So we have to find the values for x, y, and z that minimize the amount of carbon. So we know that the volume is 500 centimeters squared, and if x is equal to the length, y is equal to the width, and c is equal to the height, we are going to obtain the volume. So, and it says right here. So now for the area, we have one rectangular that has the dimension of x and y, and we have it here. Then we have two rectangles with the dimension of y and z, that is this one and this one. And then we have two rectangles with the dimension of x and z, that is this one and this one. And with this we are going to obtain the area. So for solve this problem, we are going to use Lagrange multipliers. So we are going to use the partial derivative in each variable. So the partial derivative of the area with respect to x is going to be equal to lambda times the partial derivative of the volume with respect to x. And also the partial derivative of the area with respect to y is going to be equal to the lambda times the partial derivative of the volume with respect to y. The area of c is going to be equal to the partial derivative of the area with respect to c, and this is equal to lambda times the partial derivative of the volume with respect to c, and we have our condition and we have to equalize it to 0. So now the partial derivative of the area with respect to x is y, this is going to be constant, and this is 2c, and this is equal to lambda times the partial derivative with respect to x, and is yc, and this is going to be constant. So we have this first equation. And now for y, the partial derivative of the area with respect to y is x 2c, and this is going to be constant, and this is equal to lambda times the partial derivative of the volume with respect to y, that is xc. And now for c, the partial derivative of the area with respect to c is, this is going to be 0, 2y, and 2x, plus 2x. And this is equal to lambda times the partial derivative with respect to c, and this is xy times lambda. And to make the volume 0, we have to pass this 500 to the other side with a negative value, and this is going to be equal to 0. So now I'm going to divide, the first equation is going to be divided by the second one. So I can cancel this lambda and this c, and now we have this. And if I pass this x to the other side, it's going to be multiplying this, and if I pass this to the other side, it's going to multiply y. After doing the multiplication, we have xy plus 2xc is equal to xy plus 2yc, and I can cancel this, and we have 2xc is equal to 2yc, and I can cancel the 2 and the c, and we have that x is equal to y. So now we have to divide the first equation is going to be divided by the third. So I can cancel lambda, I can cancel the y, and we have this. And if I multiply, if I pass to the other side, it's going to multiply this, and if I pass this to the other side, it's going to multiply c. So now I can cancel 2xc with 2xc, and we have that xy is equal to 2yc. So I can cancel the y, and we have x is equal to 2c. And to know the value of c, I have to pass this 2 that is multiplying to the other side, dividing. So we have c is equal to x divided by 2. And now with our equation of the volume, we now know that y is equal to x. So I can put the value. And c is equal to x divided by 2, and what we have here. and minus 50 is going to minus 500 is going to be 0. So now x times x is x power 3 divided by 2, and I have to pass this to the other side, and it's going to change the sign. It's going to be now positive, and this 2 is divided, so I pass it to the other side multiplying, and we have 1000. So if I apply this cubic root in each side, we are going to have the x alone with any number right here. So doing this, we have that x is going to be equal to 10 centimeters, y is going to be that equal to x, so it's 10 centimeters, and we know that c is equal to x divided by 2. 10 divided by 2 is 5. So now we can obtain the area with our equation, and I have it right here again. So 10 by 10, 100, 2 by 10, 20 by 5, 100, and the same here. 2 by 10, 20 by 5, 100. And 100 plus 100 plus 100 is equal to 300 centimeters squared. So this is with these dimensions, we minimize the amount of carbon, and this is going to, with these dimensions, for x for the length, y for the width, and c for the height, this is the minimum amount of carbon. And I have an example right here. So x, that is the length, is 10 centimeters, y, that is the width, is 10 centimeters, and c, that is the height, is 5 centimeters. And we have that the volume is 500 centimeters, and we have used the minimized amount of carbon. And the area of this box is 300 centimeters squared. This is all from me. Thank you so much.